Factorise means to put back into brackets. If we've got a quadratic in 3 terms, it will always factorise into what we call double brackets. If the quadratic starts x squared, each bracket will start with a single x. To find our two numbers, we need to find the two numbers that multiply to give us to what we call our constant, i.e. the number term, the term that has no letters associated with it, and the same numbers must still add to give us the number in front of the single letter. For question A, again we've got 3 terms, a quadratic in terms of x. So I'm going to start by opening my double brackets. As it starts x squared, I place a single x inside each bracket. In this case, I want to find two numbers that multiply to give us the constant, which in this case is plus 12, and still add together to give us the number in front of the single letter, which in this case is plus 7. If both terms are positive, I know the signs inside the bracket are both positive. Listing out my factors of 12, I'd have 1 and 12, 2 and 6, and 3 and 4. The only pair that multiply to give us positive 12 and add together to give us plus 7 is going to be 3 and 4 in any order. For question 2, this time I've got a quadratic 3 terms in terms of y. So again, it's going to factorise into double brackets. As it starts y squared, each bracket will start with a single y. In this case, I want to find two numbers that multiply together to give me the constant, which in this case is plus 30, and the same numbers must add together to give us a number in front of the single letter, which in this case is plus 13. Again, if both terms are positive, I know the signs inside the brackets are both positive. Our factors of 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. The only pair that multiply to give us plus 30 and add together to give us plus 13 will be plus 3 and plus 10 in any order. For question C, once more I've got a quadratic in terms of m. 3 terms going to factorise into double brackets. As the quadratic starts m squared, each bracket in this case will start with a single m. In this case, I want to find two numbers that multiply to give us our constant, which in this case is plus 7, and the same numbers must still add to give us a number in front of the single letter, which in this case is negative 8. If our constant, our number term, is positive, and the number term in front of our single letter is negative, and the signs inside the bracket are both negative. 7 is prime. The only way to get prime number is 1 in itself. So in this case, my two numbers are going to be negative 1 and negative 7 in any order, because negative 1 times negative 7 will give us plus 7, and negative 1 subtract 7 will give us negative 8. For part D, this time I've got a quadratic 3 terms in terms of a squared. Therefore, it's going to be double brackets. As my quadratic starts a squared, each bracket will start with a single letter of a. In this case, I want to find two numbers that multiply to give me the constant, i.e. the number term, which is plus 25, and the same numbers must still add to give us the number in front of the single letter, which in this case is negative 10. The only way to get a positive constant and a negative value in front of the single letter is for both signs inside the bracket to be negative. Listing out our factors of 25, we'd have 1 and 25 and 5 and 5. The only pair that multiply to give us plus 25 and add together to give us negative 10 is going to be negative 5 and negative 5. As negative times negative gives us a positive, and negative 5 subtract 5 gives us negative 10. We could also rewrite that as a minus 5 in bracket, all squared. For question E, once more I've got a quadratic, 3 terms in terms of n. Therefore it's going to factorise into double brackets. As the quadratic starts n squared, each bracket will start a single n. In this case, I want to find two numbers that multiply together to give us what we call our constant, our number term, which in this case is negative 10, and the same numbers must still add to give us the number in front of the single letter, which in this case is negative 3. The only way to get a negative number when multiplying is to have one positive and one negative. Therefore, if our constant is negative, we always know we have to have one positive and one negative inside our bracket. In this case, I'm going to list out the factors of 10. They are 1 and 10 and 2 and 5. The only pair that's going to multiply to give us negative 10 and add together to give us negative 3, in this case, is going to be plus 2 and minus 5. As 2 times negative 5 is negative 10, and 2 subtract 5 is negative 3. The plus has to be with the 2, and the minus must be with the 5. For question F, this time I've got a quadratic in terms of x, so double brackets. As it starts x squared, each bracket will start with a single x. In this case, I want to find two numbers that multiply together to give us our constant, which in this case is negative 9, and the same two numbers must still add together to give us the number in front of the single letter, which in this case is plus 8. Again, if our constant, our number term, is negative, the only way to get a negative when multiplying is to have one positive and one negative in our brackets. The only way to get 9, factors of 9 are 1 and 9, or 3 and 3. In this case, the only pair that multiply to give us negative 9 and add together to give us plus 8 is going to be plus 9 and minus 1. As 9 times negative 1 is negative 9, and 9 subtract 1 gives you plus 8. The plus has to be with the 9 and the minus must be with the 1. For question G, in this case I've got a quadratic 3 terms in terms of y. Therefore I'm going to have double brackets. As it starts y squared, I'm going to have a single y in each bracket. In this case I want to find two numbers that multiply to give us our constant, our number term, a term that has no letters associated with it, which in this case is negative 56. The same two numbers must add to give us the number in front of the single letter. If there's no number in front of a single letter, we know the number is 1. So here negative y is the same as negative 1y. So therefore I want to find two numbers that multiply to give us negative 56 and still add together to give us negative 1. Again, the only way to get a negative when multiplying is to have one positive and one negative. Listing out our factors of 56, the only pair that multiply to give us negative 56 and add together to give us negative 1, in this case has to be plus 7 and minus 8. Because 7 times minus 8 gives you negative 56, and 7 subtract 8 gives you negative 1.